Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why some of the smartest people in psychology might not be teaching the most important things they should be? Today we're diving into a really interesting piece that talks about how clinical psychology training programs are doing. It looks at whether they're teaching the newest and most important ways to do research, which they call open science. Basically, it asks if we're setting up future psychologists for success in the best way possible. The main idea here is that the way we train clinical scientists, the people who become psychologists and researchers, might be stuck in the past. These researchers looked at what is being taught in a bunch of psychology PhD programs. They found that a lot of these programs are not really teaching students about open science, which is a big deal for making sure scientific research is trustworthy and can be repeated by others. So imagine you are training to be a super detective and you are being taught how to look for clues. But what if you are not being taught all the newest forensic techniques or how to share your findings with other detectives in the clearest way possible? That is kind of what this paper is hinting at for clinical psychology training programs. The study we're talking about today actually builds on some great work by other researchers, Van Til and his colleagues. They found that open science training is pretty rare in many clinical psychology doctoral programs. This current paper applauds that research and says, okay, that is a huge problem, but it is also just one part of a bigger picture. They argue we need to really rethink how we train clinical scientists, not just add on a little bit about open science here and there. Let's get into it. The authors are super impressed with Van Til and his team's work. They looked at what was taught in research methods classes and what students themselves thought about learning open science. And surprise, surprise, students were really eager to learn more, but programs weren't offering it much. This is a big deal because science needs to be reliable, and open science practices help with that. But here's where they add their own twist. They say that just telling programs to teach open science isn't enough. There are bigger systemic issues at play. Think of it like this. If you want to get everyone to start recycling, just telling kids to recycle isn't going to work if there aren't bins available, if the garbage trucks don't pick up the recycling, or if nobody's offering rewards for it. They talk about barriers for professors. Senior professors, for example, are often swamped with administrative tasks and program goals, and even though they might think open science is important, they might not have the time or energy to really integrate it into their teaching and mentoring. They're already working like crazy, like 60+ hours a week, but a lot of that isn't even directly research or teaching. And for these newer professors, they're trying to build their own careers, get tenure, publish papers, and build a research lab. Open science practices, like pre-registering studies or sharing data, can sometimes take more time and resources up front. So even if they believe in it, it might get pushed down the list when they're juggling so much already. This part is really important. They point out that women and faculty of color often have even more on their plates. They're underrepresented in science, and they often end up doing more service work, like committees and mentoring, that doesn't always count towards promotion and tenure. This means they have even less bandwidth to champion new training methods like open science. And it is unfair if they're then judged as less rigorous, just because they might not have the resources to adopt every single open science practice. This is especially tough when these very researchers are often studying important topics like health equity. The authors strongly suggest that professors, especially those with more experience and influence, need to step up. They can change what is taught in classes and even influence what is required for graduation. They can advocate for open science in places like accrediting bodies, which decide what programs need to teach, and in committees that decide on job promotions. It needs to come from the top. Now, let's flip it and think about the students. What is it like for them? Graduate school is already incredibly demanding. They're taking classes, writing a thesis, working on research, often teaching, and trying to get those first few publications out. In those first couple of years, it is a whirlwind of deadlines and expectations. They're also trying to figure out the culture of their program, their lab, and the academic world. Trying to squeeze in learning and practicing open science on top of all this is a huge challenge. But there are good ways to tackle this. They suggest integrating open science into courses students are already taking, or even making it part of their big projects, like their comprehensive exams or dissertation proposals. Think about it. If you have to pre-register your dissertation proposal, that is already a built-in open science practice. And it's not just about what the program requires. The whole field needs to get on board. Right now, the focus for getting hired is often just on how many papers you've published. If hiring committees and professors start valuing open science practices more, students and their mentors will naturally start valuing them too. It's about shifting what we consider to be good science. This leads to a super important point. Change needs to come from the top. It is not just about individual researchers deciding to do things differently. University leadership, funding agencies, and groups that give accreditation all need to make open science a priority. When these big players start valuing open open science in their decision-making, it stops being a choice for a few brave souls and becomes the expected way of doing things for everyone. This also makes it more accessible and equitable for all scientists. Now, here is the other big part of their argument. Open science is important, yes, but it is not the only thing that modern clinical psychology training is missing. They argue that training programs are overloaded, and we need to think about the curriculum as a whole. Besides open science, there are other essential areas that are often underexplored. They mention addiction science, understanding how to actually get treatments used in the real world, that is implementation science, community-engaged research, and methods for studying individuals' deeply idiographic methodology. This is a tough balancing act. On one hand, you need strong research skills, and open science fits there, but you also need excellent clinical skills. And there are huge gaps in both. For instance, addiction is a massive problem, and yet only about half of graduate students get any real training on it in their classes. And only a third of programs even offer specialized training in addiction. This is crazy considering how many people struggle with addiction and how often it shows up in therapy and research. They also talk about implementation science. This is about taking what we learn in the lab and actually making sure it gets used by people in real life. But hardly any programs teach this. Imagine discovering a great new therapy but having no idea how to actually get it to the people who need it. That is where implementation science comes in. Community-engaged research is another big one. This approach works with communities to decide what research is important and how to do it. It's about partnership. They even point out that sometimes open science, with its focus on data sharing and statistical rigor, can seem a bit at odds with community-engaged research, which emphasizes co-creating knowledge with community members. But they also say there are ways to bring these together, focusing on shared goals like accountability and transparency. And one more thing, even if we do open science perfectly and eliminate all bad research practices, it might still not be enough to solve what's called the replication crisis. The replication crisis is basically when studies can't be repeated with the same results. They argue that some of the very nature of studying human behavior, how dynamic and individual it is, makes it hard to get the same results every time. Even with open science, we need deeper training in how to measure things accurately and methods that can capture how people are different and change over time. So, what is the solution? They say we can't just keep adding more and more to an already packed curriculum. We need to fundamentally rethink what is required. It is about making tough choices and restructuring what is essential for training the next generation of clinical scientists. They suggest that for now, weaving these new topics into existing courses and projects is a good interim step. To wrap it all up, the authors really commend the effort to highlight the need for open science training, but they emphasize that it is just one piece of a much bigger puzzle. We need to address the systemic barriers faculty face, the overwhelming demands on students, and the fact that there are many other crucial areas of training that are currently lacking. Their big takeaway is that making real improvements in how we train clinical scientists means we need to look beyond just adding open science to the curriculum. We have to re-envision what our systems value, what incentives we offer, and how we evaluate success. Open science is a crucial step, no doubt. But it is part of a larger effort to make clinical psychology a more robust, transparent, and effective field for helping people. What I love about this paper is how it takes a really important issue like open science and places it within the broader context of academic training. It is easy to say, teach more open science. But it is much harder to implement when you consider the pressures on professors, the limited time students have, and the fact that there are other critical areas also being neglected. It makes me think about how we can support faculty who are champions of open science, how we can better integrate these principles into existing coursework instead of just layering on more requirements, and how we can collectively shift the incentive structures in psychology so that transparency and rigor are rewarded as much as, if not more than, sheer publication volume. For future research, it would be great to see more concrete examples of how programs are successfully integrating open science alongside these other mentioned areas, and how they're measuring the impact of these changes on both trainees and the quality of research produced. Thanks for sticking with me on this deep dive. If you found this helpful, please give us a thumbs up, subscribe to Rubin's Mind Lab for more science breakdowns, and let me know in the comments what other research topics you'd like us to explore. See you next time.